We have seen algebraic identities in previous classes. So for polynomials, we have 4 key identities. X plus y whole square is equal to x square plus 2xy plus xy square. Identity 2, x minus y whole square is equal to x square minus 2xy plus y square. Third one is x square minus y square is equal to x plus y multiplied by x minus y. Identity 4 is x plus a multiplied by x plus b is equal to x square plus a plus bx plus ab. We'll look at certain examples on each of these identities. So let's go have fun. Let's look at some examples for identity 1. Now, in this case, I'm obviously telling you that we are going to use identity 1, but as you practice more and more, you'll be able to identify the right identity for the problem statement. So let's say someone asked you to multiply x plus 3 and x plus 3. Now, since the constant values 3 and 3 are the same, we can say that this is a y. Therefore, we can use identity 1. So, we would get x square plus 2 into x into value of y is 3 plus value of y 3 to the power of 2. So, you get x square plus 6x plus 9. Let's say we have another statement, x minus 3 multiplied by x plus 5. Now here the values minus 3 and 5 are distinct. So we'll use identity 4, which is basically x plus a multiplied by x plus b is equal to x squared plus a plus bx plus ab. So if a was minus 3 and b was plus 5, you would get x squared plus minus 3 plus 5 x plus minus 3 into 5. So x squared plus 2x minus 15. On a fine day, if somebody told you to find the solution to 105 multiplied by 106, how would you go about it? Will you actually sit and multiply these two terms? If you are smart, what you do is apply the algebraic identity. In order to do that, you will convert these two terms 105 and 106 into x plus y format. So you get 100 plus 5 multiplied by 100 plus x, 6. So now you can quickly apply the identity. So you have 100 to the power of 2 plus 5 plus 6 of 100 plus 5 multiplied by 6. Therefore, you get 10,000 plus 1100 plus 30, and hence 11130. Hey, look at this, so quick. Let's look at one more sum. If somebody tells you to factorize 49a square plus 70ab plus 25b square, the first step you have to do is to factorize each of the coefficients in these terms. So 49 is essentially 7 multiplied by 7. So you get 7a whole square. 70 is 7 multiplied by 10, and 10 can further be broken down. We'll look at it. 25 is 5 into 5, right? So you get 7a square plus, here 10 can be written as 2 into 5. So 2 into 7 into 5 ab plus 5b square. So this 7 and a can be put together and 5 and b can be put together. So 7a square plus 2 of 7a of 5b plus 5b square. Now this is a format we have seen before, which is x square plus 2xy plus y square. Now we just compare the terms on both the sides. You get x is equal to 7a and y is equal to 5b. So the factors would be 7a plus 5b multiplied by 7a plus 5b, or just 7a plus 5b to the power of 2. Let's try and factorize one more problem. 25 x square by 4 minus y square by 9. Now in this, 9 is a square of 3, 4 is a square of 2, and 25 is a square of 5. So 5 by 2 of x square minus y by 3 of square. We know the identity. Let's factorize another expression. So 25 by 4 x square minus y square by 9. In this we know that 25 is square of 5, 4 is square of 2, and 9 is square of 3. Therefore 5 by 2 of x square minus y by 3 of square. This is of the form x square minus y square, which can be factorized as x plus y multiplied by x minus y. Therefore, the factors of this expression are f 5 by 2x plus y by 3 multiplied by 5 by 2x minus y by 3. Isn't this? So far we looked at identities of binomials where there were two variables. Let's look at some more identities where the number of variables are more. So you have identity 5, which is x plus y plus z square. This can be expanded as x square plus y square plus z square plus 2xy plus 2yz plus 2zx. The next identity would be identity 6, x plus y whole cube. This is equal to x cube plus y cube plus 3xy multiplied by x plus y. In the next section, we'll solve certain problems using these identities as well. But before we go, let's look at identity 7 and identity 8, which is x minus y of cube is equal to x cube minus y cube minus 3xy multiplied by x minus y, and identity 8, which is x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx. Let's look at a small example. If somebody told you to find out 999 to the power of 3, how would you go about this? See, there are two ways, broadly speaking, and there can be multiple ways, but let's look at two ways. One is you split 999 as 900 plus 99. Now, carrying out operations on 99 is not as straightforward. But if you split 999 as 1000 minus 1, this seems much easier. So, if you wrote 999 as 1000 minus 1 to the power of cube and then use the identity, sorry, so x minus y of cube is equal to x cube minus y cube minus 3xy x minus y, and you just replace the numbers. So you get 1000 to the power of 3 minus 1 cube minus 3 of 1000 multiplied by 1, and again 1000 minus 1. So here you get 1000 to the power cube minus 1 minus 3000 multiplied by 999. So here you just have to calculate 999 into 3. So you get this large number minus 1 minus 2,997,000, and the result is 997,002,999. So in this case the only complicated calculation you had to do was in this, which is 999 multiplied by 3, which is not that typical if you look at it, because if you take out 9 from 999, you are left with this 27 multiplied by 111, which can be solved for a little easily. Right, so you have 7, 9, 9 and 2, which is what we put here.